Many substances can conduct electricity. Metals, graphite and a few others do so by means of delocalized electrons that can carry the charge. In most compounds encountered in chemistry though, the charge carriers are ions, electrically charged forms of atoms. Pure water contains no ions to speak of and so does not conduct electricity at all. The LED in this conductivity meter does not light. Tap water, however, is not quite pure. It contains small quantities of dissolved solids, and these are enough to allow a small current to flow. You can clearly see the LED lighting up. Seawater contains quite a lot of salt, about 3.5%, and so is a good conductor. This time you can clearly see the LED shining brightly. Not all compounds contain ions. In this example you'll see that there is no light from the LED when dipped into water containing sugar. Sugar, sucrose, is a covalent compound and there are no ions to carry the charge. The brown sugar does light up the LED a little. This is due to ionic impurities in this less refined product. And the salt water causes the LED to light up as before. You do need, however, more than just the presence of charged particles to get a current to flow. The particles need to be able to move in order to carry the charge. As you can see in this diagram, in a solid ionic compound, the charged particles are not free to move. A good demonstration of this is to try to pass a current through a solid salt, without success, and then to melt the solid. This particular example uses lead bromide as it has a very low melting point. It's being done here on a microscale as the reaction gives off toxic fumes of bromine. As you can see, once the power supply was actually turned on, the LED glows brightly. When the heat is removed, however, the lead bromide cools and you can see that the LED slowly fades and then goes out. As the lead bromide solidifies, the ions can no longer move and so no current can now flow.